Hello, so let us start with a problem on multisets. So the question is, find the number of R element multi-subsets of the multiset m equal to, so we have 1 times a1, then infinity a2, infinity a3, so on infinity dot an. So we need to find out the number of R element multi-subsets of the given multiset M. Now for this problem, we can consider two disjoint cases. The first case is where your given multi-subset will contain A1, and the second case is where the R element multi-subset does not contain A1. So let us see what are the different possibilities in each case containing A1 and not containing A1, and the sum of those two disjoint cases will give you the total number of R element multi-subsets. So there are two disjoint cases. So case 1 is the multi-subsets contain A1. Now let us see how many R element multi-subsets are there such that it contains A1. So if it contains A1, now A1 cannot be repeated. A1 എന്ന് പറയുന്ന object ഒറ്റ തവണ മാത്രമേ യൂസ് ചെയ്യാൻ പറ്റുള്ളൂ. So all the other objects can have infinite number of repetitions. So if it contains A1, then A1 is already there. അപ്പോൾ നമുക്ക് ബാക്കി, so you need to form R element multi-subset. So out of the R element, one element is fixed already. So one element A1 ആണ്. ബാക്കി നമുക്ക് R minus 1 objects ആണ് choose ചെയ്യേണ്ടത്. So the R minus 1 objects have to be chosen from the multi-subset which has n minus 1 elements. So if it contains A1, then the number of multi-subsets will be, so that will be equal to H. So you need to choose R minus 1 objects out of n minus 1 objects, so that can be done in n minus 1 plus R minus 1 minus 1 R minus 1. So that is equal to n plus R minus 3 C R minus 1. Now that's the first case. Now case 2 is when, so case 2 is the multi-subsets does not contain A1. So the multi-subsets does not contain A1, so A1 is not a member of the multi-subset. So you have to choose R objects. The R objects have to be chosen from n minus 1 distinct types. So the number of multi-subsets will be, so that will be equal to, so in place of n you have n minus 1. So n minus 1 plus R objects ആണ് choose ചെയ്യേണ്ടത്. So okay, this will be, so let us write first in terms of HNR. So this will be HN minus 1 R ആയിരിക്കും നമുക്ക് വരും. So that will be n minus 1 plus R minus 1 C R. So that will be equal to n plus R minus 2 C R. So therefore by addition principle the number of multi-subsets will be, so that will be the sum of the disjoint cases, so that will be n plus R minus 3 CR minus 1 plus n plus R minus 2 CR. So that is the required number of multi-subsets. And now let us move on to what is called as distribution problems. So by distribution problems we mean that is a number of ways of distributing R objects into n distinct boxes under certain specific conditions. Here, so you are having R objects. So R objects are to be distributed to n boxes. So we will have certain conditions in these n boxes. So there can be restrictions allowed in each box. So that gives rise to different distribution problems. ഇനി നമ്മൾ എടുക്കുന്ന കേസിൽ, so here the n boxes are distinct. Now the R objects, they can be distinct or they can be identical. So those are the two categories of distribution problems. The first category is where the objects are distinct, and the second category is where the objects are identical. So in distribution problem, so we count the number of ways of distributing R objects to n distinct boxes under certain conditions. So there are two cases. So first we will consider the case when the objects are distinct. So there are two cases when the objects are distinct, and the second case is where the objects are identical. So first we will see the case where the objects are distinct. So now first let us see. Okay, so let us see distributing R distinct objects to into n distinct boxes. So we will see the distribution under certain conditions. So the first condition is, so if each box can hold at most one object, so that is the first condition. So you need to find the number of ways of distributing R objects into n distinct boxes. So each box can hold at most one object. So here the number of objects will be less than the number of boxes. So here, so there are total of R objects. So there are R objects. So let me take as object 1, object 2, and object R. Okay. Now if you look at the first object, so first object, each box can hold at most 1 objects. So let us see the number of ways of distributing R objects to these n boxes. അപ്പോൾ ഓരോ ബോക്സിലും ഒരു ഒബ്ജക്റ്റ് മാത്രമേ പറ്റുള്ളൂ. So now you take the object 1. So object 1 can go to any of the n boxes. And when you take object 2, object 1 ഇരിക്കുന്ന ബോക്സിലേക്ക് പോകാൻ പറ്റില്ല. So it will have n minus 1 choices. So if you take object 3 can go to n minus 2 boxes, so it cannot go to the first 2 boxes. And object R can go to n minus R minus 1 boxes. So therefore the number of ways is equal to n into n minus 1, n minus 2, etc. n minus R plus 1. So that is the value of PNR. So the number of ways of distributing R objects to n boxes, where each box can hold at most 1 object, is given by PNR. And the second case is if each box can hold any number of objects. And then the number of ways is, so each box can hold any number of objects. So total there are R objects with us. So you have object 1, object 2, object 3, so on object R. Now when you take object 1 can go to all the n boxes because each box can hold any number of objects. അതുപോലെ object 2 എടുത്താൽ object 2 can go to the first box also. So again it will have n choices. And when you take 3, object 3 can go to all the n boxes. So on object R can go to all the n boxes. So therefore the number of ways will be equal to n power R. So that is the required number of ways. Now let us see. Okay, let us stop with that for today. So we will continue in the next class on the distribution problems.